So there's something in quadratics called a perfect square. Does anybody know what that is? You should do, because some of you would have seen it just the other day. Travis? Yes, x squared minus 9 is a perfect square. No, x squared minus 9 is not a perfect square.
There's like 9, 16.
No, those are square numbers, 9, 16 and 25, but a perfect square is a quadratic
where the brackets are the same.
Where the two brackets are the same and there's a squared outside. So something like this is a perfect square, all right? Because the two brackets give the same solution. Now, we want to be able to write equations in this form. So we want to be able to start with an equation and turn it into something that looks like that. So what the completed square form, CSF, completed square form, looks like is sometimes an A out here, but not very often. That. Now, both B and C can be negatives, so those positives can be negative signs. But what we've done is we've made it into a square here and an extra number. This number out here presents a little bit of a problem, so we'll start off without having one. So if we've got the quadratic x squared plus 6x plus 9. This is a perfect square because it doesn't actually get completed, it changes into a completed square that actually has no C. So what we do to make this into a completed square form is we look at this term here, this one here, which we usually call A, B, and C, all right? And we halve that B. So if we halve 6 and put it in the bracket, all right, that's how we get that first part of our completed square form. It's as easy as that. Halving that number here, putting it in the bracket. What we then have to do is see if we've introduced anything. So by looking at what this multiplies out to, we've got x squared plus 6x plus 9. It didn't introduce anything, so this actually is our answer. We compared this to find out whether this is our answer. So that was a straightforward one. If we were trying to do this to something that we couldn't just have done without using the method, all right, we can use it to solve, so we're going to go all the way through today. So in this case, what are two things that multiply to give 2 and add to give 4? Nothing, right? There are no things that multiply to give 2 and add to give 4. So therefore we can't factorise it. We have to use something else to help us to solve. So what we use is this method here, where we halve this and put it in brackets. So half of that is 2 plus 2. We get that. When we multiply this out, it equals x plus 2 times x plus 2, which equals x squared plus 4x plus 4. So we would have loved it to have been that, because then this would have been the answer, but it wasn't. It was minus 2. So what we have to do now is think, okay, we want that. We've made a plus 4. We've made a plus 4, but we want minus 2. This is what we've got at the moment, but what we want is this guy, minus 2. What can I do to this, which is that, to get a minus 2? Take away 6. Then take away that 4, because I don't want it. I actually want negative 2. So I'm going to take away that 4 and take away an extra 2 to get to that negative 2. So I'm going to minus 6. So to do that, so take away the 4, that's that one, and minus the 2. We've actually got this. That thing up there is exactly the same as this. They're equal. We've completed the square on it, equal to 0. Now, why do we want to do that? Because we can't factorise that, we also can't solve it, because we don't know what the factors are, so we can't put them out of the brackets, change their signs, etc. But we can do it to this. We can take this and solve it by making it equal to 6, all right? Getting rid of the squared. What do we do to get rid of a squared? Square root. We have the positive and negative square root of 6 because we don't know which one it was. We don't know which one, whether it was the positive square root or the negative square root, so we have to cover our bases and write both of them. Now we want to get rid of that 2, so x equals, getting rid of that 2, bringing it onto this side, we've got negative 2 plus or minus square root of 6. Those are our two answers to our quadratic. Remember, generally, quadratics have two answers. So that's a nice easy one, and it's easy because that's an even number. Should that be an odd number, it becomes a little bit yuckier. We're actually going to do a really yucky one now, because a really yucky one actually could be an excellence question in the exam. So why not have an example of a yucky? So if we've got 3x squared plus 9x minus 21. No, minus 19 equals 0. All right. I got rid of the 21 because I realised they were all factors of 3, and then you could have just all taken the 3 out, and that would have been the easiest way to do it. But I don't want to do that. I want to see that I can't take the 3 out of here. So I want to actually leave that bit here for a later date. Just going to deal with this part here. So I'm going to factorise it. 3 bracket x squared plus 3x. Going to make it equal to 19. Leave that bit over there for now. So now I'm at the point of having an a. That a is 3. What I need to do now is I need to complete the square on this. So completing the square on this is 3, half of 3 is, I don't write it as 3 over 2, it is 1.5 and there's no x, squared. But now I have to again find out what I've introduced. Are we writing this down, Luke?
Yeah.
Good. So when we write this down, we need to make sure that we are multiplying out the two brackets. So we get x squared plus 3 over 2 plus 3 over 2. 3 over 2 plus 3 over 2. 3. 1.5 plus 1.5, 3x. We pretty much can guarantee that that will be it because that's what it was. Now we need to do 3 over 2 times 3 over 2. When we multiply fractions, we multiply the top and we multiply the bottom. All right, so we've introduced a 9 over 4. So we need to get rid of that 9 over 4. And we've already moved this 19. So here we've actually got, yeah, it's a bit of a process. We just have
to use fractions now?
No, you could use decimals.
Because isn't that just introducing a working step for us?
No, because I'm going to keep fractions in mine. So that 9 over 4, I like fractions. Fractions are very helpful. They keep exact answers. that 9 over 4 is equal to 19. All right, so I took that 9 over 4 off, this one here, because I needed this to be equivalent to that, and it didn't have a 9 over 4. So this is now in completed square form if I put that over there and made it equal to 0, but I don't actually want to do that because I'm solving. I actually want to bring that over here. So I want to get it to the stage where it's adding 9 over 4. 9 over 4 is 2 1/4, right? So 21 1/4. I'm now going to divide by 3. (21 1/4) divided by 3. 7 1/12. Want to check? 21 1/4 divided by 3. No? You all want to believe me? Now we're going to take the positive and negative square root. Of 7 1/2 and a 12, positive and minus. So the answers are that. The answers to that equation are 1 1/2 plus the square root of 7 and I can put that in my calculator and get some decimal answer too and write it down. But this is absolutely fine because that's a perfect answer found from using completed square form. So what we need to be able to do is we need to be able to change this without an equals to write it like that. We also need to be able to use it to solve an equation. Remember that quadratics always start equal to 0. If they're not, we make them equal to 0.